Hello everyone and welcome to Excelsior. Did you know that there are hidden lines in your NCERT textbook which can make JEE Mains Physics questions surprisingly easy? Yes, you heard that right. Today we are going to solve an electric dipole question from JEE Mains 2024 paper and cover some common silly mistakes to boost your understanding. Okay, so let's get straight to the question. The question says, two charges of -4 microcoulomb and +4 microcoulomb are placed at the points A104 meter and B2-15 meter located in an electric field vector E equals 0.2 I cap volt per centimeter. The magnitude of the torque acting on the dipole is 8 root alpha into 10 to the power minus 5 Newton meter, where alpha is equal to. So the value of alpha you have to find here, all right? And the value of torque has been given in Newton meter units, okay? So we will have to be careful for this, okay? Now in the question, vector E has been given is 0.2 I cap volt per centimeter. So we will first convert it into volt per meter format and it will become equal to 20 I cap volt per meter, okay? And the positions of the two charges have already been given in meter units, okay? As you can see here, all right? Now 4 microcoulomb is 4 into 10 power minus 6 coulombs. You already know basic mathematics. Vector E we have already converted into volt per meter format. Now, what is torque? If an electric dipole is placed in an uniform electric field, so the torque acting on the dipole is given as tau vector equals vector P cross vector E. Okay, so it is given in the vector format. And vector P is electric dipole moment, and vector P is expressed in Q into L vector, where Q is magnitude on either of the charges. All right. And vector L is position of positive charge with respect to the negative charge, because you know by the standard conventions we know that the electric dipole is directed from the negative charge to positive charge, right? So we will calculate vector L first. So what will be vector L? Final position minus initial position. So vector L can be expressed like this: 2 minus 1 I cap minus 1 minus 0 j cap 5 minus 4 k cap, which comes out to be I cap minus j cap plus k cap, right? So vector P becomes Q into L vector, where Q is 4 into 10 power minus 6 and L vector is like this. Okay, now we will calculate the value of tau vector. So it will become vector P cross vector E. Okay, so the constants will come outside like this, and we will cross product the vectors inside this square bracket. Now you know this trick. I know many of you might know this trick, but here I will repeat it again. So if you have to calculate cross product of unit vectors I cap, j cap, k cap, so it goes like this. In clockwise direction, I cap cross j cap will give you k cap, j cross k will give you I cap, and k cross I will give you j cap. But if in counterclockwise direction, I cross k will give you minus j, k cross j will give you minus I, and j cross I will give you minus k. All right. So the cross product here has been given here. I cross I will be 0, right? And j cross I is equal to minus k cap. So minus minus plus. So k cap and k cross I is j cap. Okay. So we have expressed tau vector here like this. Now the magnitude of the tau vector will be given as 8 root 2 into 10 to the power minus 5 Newton meter, because you calculate magnitude of this vector like this. Okay. So the value of alpha comes out to be 2. Now you also know that if there is any vector, in this vector, the length of this arrow will give you magnitude. And this direction is represented by its unit vector. So if vector L is given like this, so suppose L is magnitude and L cap is direction, unit vector. Okay. So what will be the length of this vector, which has been directed from negative charge to positive charge? Okay, we are talking about this length. So this length will come out to be root 3. Okay, x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 whole square and whole under root, right? So it will come out to be root 3. All right. So vector P you can also write as vector P equals to magnitude of the charge, length of the vector, and its direction, that is given as unit vector L. Okay, so see what happens. Sometimes students forget expressing this electric dipole properly. Okay, if they do not express it properly, they will do some mistakes, and what are those mistakes we will talk about here. See, vector P is equal to 4 into 10 power minus 6 into root 3 I cap minus j cap plus k cap. What we have missed here? We have missed upon under root 3. Okay, if you miss this upon under root 3, okay, if you miss this upon under root 3, so you mistakenly will write this as this vector product. You will mistakenly write this as like this: 4 into 10 power minus 6 root 3 I cap minus j cap plus k cap cross 20 I cap, and you will do cross product like this, and in the end you will get the value like this: 8 root 6 into 10 to the power minus 5 Newton meter. Okay, you have done everything properly, but you forgot to put this root 3 in the denominator. Okay, so in hurry these kind of mistakes happen. Okay, these kind of mistakes happen, so you have to be careful for this. You have to be careful for this. All right, you have to be careful for this. If you are expressing vector L in electric dipole formula, if you are expressing vector L like this, Q into L cap, sometimes student remember this as well. So these mistakes can happen. All right, so be careful about this. Another mistake is not observing units properly. Okay, so 0.2 I cap volt per centimeter. If you don't convert it into volt per meter, you might get stuck somewhere in the calculation, and you will come back again and again to find the mistake that you have already done. Okay, so it will consume more time, and you might miss other questions, other easy questions as well. Okay, so you have to be prepared for this. So look after what in the question is asking. The question simply asks you to calculate the TAR and express it in this form. All right, in this form. So this is all about this question, and the line that I talked about in the NCERT is this. Here you can see the NCERT textbook, Physics Part 1. It has been mentioned here, the dipole moment vector P of an electric dipole is given by vector P equals Q into 2A P cap. That is, it is a vector whose magnitude is Q charge times the separation 2A between the pair of charges, and the direction is along the line from minus Q to Q. Okay, so if you get these type of questions, see, hidden lines have already been given in the NCERT, which has made this question very easy. If you did not know the concept of that dipole is directed from negative charge to positive charge, so you will get stuck in this question. Okay, you will get stuck in this question because you don't know the basic concept. So it has been already given in the NCERT textbook. Okay, so this is what I wanted to talk about in this video. We will come back with another video. Until then, stay curious, stay safe, and if you have liked this video, so please subscribe to the channel, share it with your other friends, so that this channel can grow and we can have a larger audience. And if you know the other silly mistakes that I have missed in this video, you can let me know in the comments so that other people can know the mistakes as well. Okay.